Actually, I was pretty much bored in my home, and I thought that let's begin doing some LeetCode problems. And in this lockdown, people are really getting frustrated, and many are losing jobs. So I thought that uh, we can start learning something new in this lockdown. So uh, I am going to make a playlist and upload several videos where I am planning to make solve multiple problems. So today I have chosen to begin with an easy problem from the topic array. Okay, so the problem title is two sum. It says that you are given an array of numbers and also an target. So what you have to do is you have to see whether two numbers in this array add up to this target. So if it does, then you have to output the indices of those two numbers who add up to the target. So in this example, as you can see, in this array 2 plus 7 gives us 9. This is the target, so the output is 0 and 1. So 0th index and first index, that is there are the two numbers who add up to the target. So okay, so let's see this problem. So here 2 plus 4 gives you 6, so the output is 1 2. So there is another condition that you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, so and also you can return the answer in any order. So the first thing that comes to our mind is brute force method. So you have to find a pair of numbers who add up to a certain value. So why not checking every pair of numbers who may add up to 9, and we will find out a certain pair whether it exists or not, and if it does, then we have to return the integers in the form of a vector. So I am using C++ here. You can choose your language of your preference as well. So let's begin. So for the brute force, as you can see that we should begin with a for loop. So let's start. So for int I equals to 0, I less than nums dot size, that will give me the length of this array, and I plus plus, and this don't know who made this rule using for I and j. So okay, and this constraint that you may assume that each input would have exactly one solution, this constraint gives us an edge that we should not begin j iterating from 0, but we should check it from I plus 1. Why? Because see, why fixing this first index I, this means we are assuming that we have to check right from the left side. So first we will see we will take into consideration these two, suppose, then we have to check whether 2 plus 7 becomes 9, then 2 plus 11 becomes 9, then 2 plus 15 becomes 9. So that this next counter should begin from the next value of I. So when we move to 7, in case the target was something else, that 2 plus 7 is not the pair, so in that case if we take 7, then we should not check 7 plus 2 again, because we have already checked 2 plus 7. So we should not go back, and again it says that you may not use the same element, so we should not use 2 times. So it is not like 2 plus 2, it should not happen. So due to these two reasons, we should begin the counter from I plus 1, that is the first element we are fixing. Then in the rest of the array, we are saying that rest of the array means at the right side of that fixed element we are saying that whether there exists one more element that adds up to that previous element to give us this target. So again, j less than nums dot size j plus plus, and see if nums I, so why not make it full screen, nums I plus nums j double equals to target, then what should we return it should be a vector, so I and j, else we should not return anything, we should just continue, but it will give me some error. Let's see. Yeah, so it says that non-void function does not return a value, so to avoid this error we should return something. Okay, so say return a void, or say 0 0. Okay, now this will not happen. Okay, it checks the first test case, passes the first test case successfully, so let's use some example test case and see whether it passes or not. So all of them pass, so let's submit, and yeah, but runtime is very high, so in any technical interview you should optimize your code. So you see, we can see that the complexity of this solution is O n square, because this outer loop is iterating n times, and the inner loop also is iterating. For each iteration of the outer loop, it iterates n times. So in language of complexity, it is O n square. So okay, so what should we do? So I saw that in the related topics there is hash table. Okay, so from there I got an idea that we should use an hash map. Why not use it? Let's see. Okay, so let's use a map. The key and value both are integer, and let's name it m. Very creative, no problem. Yeah, so we should insert the first item in the map. So what are we going to do? We are when we visit the first element, we are going to store that into the map, hash map, and in this way we will run over the array, and every time we will subtract that current element from the target and see whether the result of after the subtraction has occurred previously or not. So in this case, when we move over to 7, then 9 minus 7, that gives us 2, and 2 we have already visited 2. So in that case, our hash map will optimize our search pattern, and will and we can solve this problem in a single pass. So okay, so I will just code it and then explain. So m dot insert, what do I have to insert? Okay, so nums 0 and 0. So the first element go inside, because we have to iterate from the second element onwards. So as it is a pair, we are assuming that if there is only one element in the array, there is no probability that it can give us a valid result. Okay, so the first element goes into the array beforehand, before we even start iterating. Okay, so now, as I have promised, that we will use a single loop. So for int I equals 0, I less than nums dot size I plus plus. Now what we have to do is we have to check whether we first have to subtract the current element from the target. So like this, target minus nums I. Okay, and we have to see whether this result of the subtraction has already occurred anywhere in the previous array or not. So what we have to do, m dot search, or what should I do, m dot search for this thing, and if this happens to be the end of the map, so then we know that it has not occurred anywhere before. So in that case we will just simply insert this element in the array, hoping that it will make up a pair in future. So m dot insert nums I and I. Else means it has occurred previously. Okay, then we have to just simply return the value, return a vector, of course. So what are going to be the contents of the vector? There is m target minus nums I. That will give us the index of the subtracted, the result of the subtraction, that is the other number of the pair, and the current element. So as you can see here, I have used indexing to extract the value of this map from this map, and here I have used the keyword search. So if you do not know that, just you can Google it, but in very short I will explain what is the difference between them. m.search returns an iterator. Okay, so it returns, in simple put simply, it is a pointer, and here m, and then if we use indexing, that it will return you the value, that is in map we use key value pair. So the key is this thing, target minus nums I, and the value is what is stored according to that key. So, and to avoid that previous error, we should just simply do this, and yeah, this will run fine, I think. Let's see. Okay, compilation error. m.search find, was it find? Okay, it gives us wrong answer. Why? Let's see. Okay, yeah. So from m I not equals I equals to 1. Yeah. So, why? Because we are beginning from the second element onwards. Yeah, it runs perfectly fine. So yeah, we have used the example test case. So let's put a submit request. Let's see what it does. Okay, it is fine. And for your reference, if you use unordered map, I think this will fast up a little bit. Okay, unordered. Okay, I missed a E. Okay, let's submit. Yeah, as you can see that it has. Yeah, so stay tuned for the next video.